So there are two types of memory interleaving techniques. One is low order interleaving, another one is high order interleaving. So consider a main memory formed with m modules. Suppose consider that the main memory having how many modules? M modules, and m equal to 2 to the power a means m equal to 2 to the power a means memory modules. So number of modules are 2 to the power a modules are there in a main memory. Okay, each module contains word equal to 2 to the power b words of memory cell means suppose this is a memory modules. So number of words are there. This is denoted as W. So how many words are there? W words are there in the module. So suppose this is a module. In this module, how many words are there? W words are there. Suppose there is m number of modules. Okay. So how we will find how many words or what is the capacity of memory? So total capacity of memory equal to number of module into each module containing words equal to, so m, instead of m we can write 2 to the power a, and instead of w we can write 2 to the power b equal to 2 to the power a plus b words. So how many words, or you can say how many, what is the total capacity of a memory? 2 to the power a plus b word, or you can say m into w. Let's consider in main memory there is 4 modules are there. So 4 modules, so 4 can be write as 2 to the power 2, that implies a is what? A is what? 2. Similarly, words, how many words in a memory? In a module, 4 words. So 4 equal to 2 to the 2, we can write b equal to 2. So total capacity 2 to the power 2 equal to 2 to the 2 plus 2 equal to 2 to the 4, that is 16 words. So this is a memory which can contain how many words? 16 words. And how many blocks are there? 4 blocks are there, and each blocks containing how many words? 4 words are there. So come to low order interleaving. So already I told you what do you mean by low order interleaving. Low order interleaving means if it is spread contiguous memory location across the m module horizontally. So in low order interleaving, the words are stored in horizontally manner. In this look this figure, data are stored in horizontal manner. 1 2 3 4, after that 5 6 7 8 9 10 11 12 13 14 15 16. So this is what? Horizontally manner. So words are stored in horizontal manner in your low order memory interleaving. And what is low order interleaving saying? Already I told you, the least significant bit or low order bit say the address of the module or number of the module, and high bit or b bit will identify the word address. Yes or no? Look here low order a bit of the memory address are used to identify the memory module, and high order b bits of the memory address are used to identify the address with each modules. Okay, suppose in a previous example I told you, suppose 8 having value 0 1 1 1. So these are called what? A order bit, or you can say this is what? Low order bit. So low order bit is used to identify the address of the module, and 0 1, the high order bit, is used to find the address of the words. Okay, so this will help you to identify the module, and in this module in which location the word is present, the high order bit will identify. Okay, so let's explain through this diagram. Come to this diagram. This is a low order memory interleaving diagrams, or you can say low order MOA interleaving diagrams, or figure of low order MOA interleaving. So how the data are arranged? Look, this is the bits. Suppose this is the bit, this is 0 1 and this is 1 1. So this is A bit and this is B bit. This is, you can say, low order bit or LSB. This is, you can say, high order bit or MSB. Okay, so low order bit is used to identify the module. So load this A bit will be passed to address decoder. And why we are using address decoder? Address decoder is used to distribute module address. So this address decoder pass the value corresponding modules. So he will the address decoder pass the A value to corresponding MAB is nothing but memory address buffer. So this memory address buffer will pass its corresponding modules. So assume that a value is what, whatever a value is that is belongs to this MAB. So this MAB inform to module 0 that you are having a words. Okay, and how, in which section the word is present, that will be identified by the help of your high order bits. So high order bit will come to, or you can say B bit will come to your WAB. This is nothing but word address buffer. So word address buffer help to identify the word in the modules. Okay, if the word is present here, let the word is present here, then the B value will be passed to here. If the word is here, then the WAB value will be passed to here. If the word is here, then the WA value will be passed to here. Okay, so look, there is number of modules are there, M modules are there, M0, M1, and M module means M minus 1. So M minus 1 modules are there. So, okay, or you can say M modules are there. Get it? If 15 modules are there, so last value will be what? 15 minus 1 means 14. Similarly, this is arrangement. So, and words are stored in which manner? Horizontal manner. So first 0 word, second word, third word, fourth word, like this. M minus word, M minus 1, then starting from M, then M plus 1, M plus 2, like this, 2M minus 1. Okay, similarly in last M into W minus 1, then next word will be add 1 here. So MW minus M plus 1. Similarly the MW minus 1 word will be there. So data are stored in horizontally manner. Okay, and so first from this bit, a bit will be passed to address decoder, and this address decoder help to identify the modules, and this address decoder pass the value to corresponding MAB. Okay, so then MAB will be pass the value to the modules. Okay, and the B bit will be passed by the help of WB into the corresponding modules. Okay, so after fetching the data will be passed to which one? MDB, and that data will, by the help of MDB, data will pass to the data bus. So after fetching the data will pass from the module to data bus by the help of MDB. This is nothing but memory data buffer, and after getting the data from the memory data buffer to data bus, the CPU or IO, whatever CPU or IO are connected to this data bus, they will access the data. So how the data will be accessed by the CPU and IO devices? By this manner. First the data will be, the low order bit will be passed to MAB, and MAB is used to find the modules, and the high order bit B will be passed to WAB, and WAB will be helped to find the word address. After getting the word, the MDB is helped to fetch the data from module to system bus, or you can say data bus, and from that data bus the CPU and IO device will get the information. Get it? So this is the infrastructure of a low order M-way interleaving. So next, what is the advantage of low order interleaving? Low order M-way interleaving support block access in a pipeline fashion, or access of the M memory module can be overlapped in a pipeline fashion. This is means you can access multiple words at a particular cycle, or you can say simultaneously we can access multiple word in one clock cycles. Get it? So in one clock cycle, CPU can access multiple data by the help of low order M-way interleaving techniques. Get it? So this is the benefits. CPU can access multiple words from the CPU from the memory at one time, and which, so by accessing multiple words from memory in one time, the execution speed will be enhanced, the performance of computer will be enhanced. So this is the advantage of M-way low order interleaving techniques, through which CPU can access multiple words from memory simultaneously at a time. Okay, so this is your low order interleaving. Okay, next come to your high order interleaving. So what happen in high order interleaving? Already I told you, in high order interleaving, suppose this is the 8, so 0 1 1 1. So this is high order bit and this is low order bit. So high order bit in case of high order interleaving, high order bit is used to identify the address of the module, and low order bits are used to identify the address of the word. Get it? So high order is denoted here A bits, and low order bits are denoted is what? B bits. Okay. So in high order interleaving, contiguous memory locations are assigned to the same memory modules vertically. Okay. So what happen in high order interleaving? So look, in high order interleaving, first point is saying that in high order interleaving, contiguous memory locations are stored in one module. Okay, look, in first module 1 2 3 4 contiguous data stored. In second module 5 6 7 8 are stored. In third module 9 10 11 12 and fourth module 13 14 15 16. So this is which manner? Vertically manner. So in high order interleaving memory techniques, data are or words are stored in vertically manners, and it is stored contiguous in location in any modules. Okay, so this is the first point saying. Okay, then second point is saying what? High order A bits of the memory address and the used to identify the memory modules. So I already told you this high order bits are used to identify the memory modules, and the low order bits and low order B bits of the memory address are used to identify the word address which within each module. So this will help to find the word address within each module. Last here already we seen 0 1 1 1. So 0 1 is used to identify the memory module. So 0 1 which one? This is memory module 2. Then word is present in which location? 1 1 location. Look, 1 1 location, 8 is there. Okay. So similarly, look this diagram. This is the diagram of high order MO interleaving. So it is similar to your low order interleaving techniques. Only small change is there. So high order bits are passed to address decoder, and this address decoder pass the data or pass the bits to corresponding MAB, and that MAB will find its corresponding modules. Okay, but in case of low order interleaving, the low order bits are passed to address decoder, and high order bits are passed to word address buffer. But here the high order bits are passed to address decoder to find the corresponding modules. Okay, so address will be so high order bits A will be passed to the address decoder, and that value passed to its corresponding MAB. Okay, and that MAB help to find the corresponding modules. Okay, then the low order, suppose A value is in module M0. Suppose A is indicating that module M0. Okay, and word bits or low order bits, that is what? Nothing but B is passed to which one? Address, word address buffer, and word address buffer is help to find its corresponding modules. So if the word is present here, then it will pass to here. If the word is present here, then it will pass to here. If the word is present here, then it will pass to here. Okay, so after getting the module address and word address, the data will fetch from corresponding modules to the data bus by the help of MDB. MDB is nothing but memory data buffer. Okay, after fetching the data from module to data bus by the help of MDB, then the CPU or IO device can access by connecting to the data bus, similar to your low order memory interleavings. Okay, so look here, in low order interleaving, data are stored in horizontal manner, but in high order interleaving, data are stored in vertical manner. Means this is word number 2 3 4 5, this n minus word, then n word or w words, then w plus 1, like this, w minus 1, then m minus w words, then m w minus m w plus 1, similarly m w minus word. So words are stored in vertically manner and modules are like in this manner. Okay, so this is the pictorial diagram of high order interleaving. Listen carefully. In low order interleaving, low order bits are passed to address bit and high order bits are passed to word address buffer. But here high orders are passed to address decoder and low order are passed to word address buffer. So high order is used to identify the modules and low orders are used to identify the word address. Okay, but in case of low order interleaving, low orders are used to identify the module address, and this is used to identify the word address. So look, in high order interleaving, in each memory cycle only one word is accessed from each modules. High order interleaving can support block access of contiguous location. This is the disadvantage. So what happen in high order memory interleaving? In high order memory interleaving, that your CPU cannot access multiple words simultaneously at a time because data are stored in horizontally manner. This is the disadvantage of high order interleaving. So look what happened here. In low order interleaving, data are stored in horizontal manner, but in high order interleaving, data are stored in what? Vertically manner. Okay, so when CPU want to access the data multiple amount of words or block of words, then he will use what? Low order memory interleaving. Means at a time he can access 1, 2, 3, 4 simultaneously by the CPU. But in case of here, data are stored in vertically nature, so he cannot access multiple words at a time because data are stored in sequential manner. Though data are stored in sequential manner, but here it is one advantage is what? Multiple processor can execute by the help of multiple modules. Means processor 1 can access this module, processor 2 can access this module, processor 3 can access this module, processor 4 can access this module. So multiple processor can perform simultaneously their task by the help of high order memory interleaving. So this is the advantage of high order memory interleaving. Get it? So what do you mean by memory interleaving? So memory interleaving is a technique used to increase the throughput of memory in computer system. The core idea is to split the memory system into independent banks or blocks which can answer read and write requests in parallel. So by the help of dividing the contiguous memory location or single memory module to multiple modules, we can achieve the parallel processings. Also we can achieve the structural hazards. Already I told you in pipelining, if multiple instruction want to access memory at a one time, then there will be create hazards. That is what? Structural hazard. So how can we overcome the structural hazard? By the help of dividing your main memory into separate modules or MOA interleaving memory techniques. Okay. So these are the techniques, and there are two types of memory interleaving techniques. One is low order memory interleaving techniques, another one is high order memory interleaving techniques. So in low order memory interleaving technique, LSB are used to identify the word module address, and MSB are used to identify the word address. But in case of high order memory interleaving, MSB are used to identify the module address, and LSB are used to identify the word address. Okay, so the main goal of memory interleaving design of memory is to broaden the effective memory bandwidth so that more memory word can be accessed for unit time. So main goal is what? To design the memory into number of modules. Main goal is what? Increasing the memory bandwidth. What? So main goal is what? To increase the memory bandwidth. We are using or we are dividing the memory into number of modules. Okay, so here more than one words can be accessed simultaneously by the CPU at one time, but here number of processor can be executed simultaneously by the help of different modules. Okay, so this is multiple words can be accessed simultaneously at one time by the CPU. Here multiple processor can be accessed at one time by using different modules. So if processor 1 need for data, then he can access this one. If processor 2 need this second data, then he can access the data. If processor 3, then he can access the data. So this is the difference. So these low order memory interleaving and high order memory interleaving having different use, and they are used in different as per the different requirement of the users. Okay, so this is all about your memory interleaving techniques. So listen the video carefully and try to solve the problems, and after solving the assignment please upload it into my WhatsApp number, or you can mail to my mail ID, and watch the video carefully. If any doubts, ask me by the help of WhatsApp number or mail ID. So this is nothing but your memory interleaving models. So memory interleaving is used to enhance the bandwidth of your computer memory, and it is have to what, achieve parallel processings, or you can say it is used to avoid the pipeline structural pipeline hazards. Okay, so this is the figure of high order memory interleaving. Okay, and this is the figure of low order memory interleavings. Okay, so in BPUT question there may be asked a 16 mark long question, what is memory interleaving, and explain different types of memory interleaving techniques with a suitable example. So you can write these things easily and you can get 16 marks. Okay, so this is all about your memory interleaving techniques. So stay at home. This is the last lecture video of module V, and we are successfully complete our module V. Look the video, try to understand properly by the help of these lecture videos, and try to solve the problems. Thank you everybody.